Speakers.
Hi everybody, and welcome to this Microsoft 365 virtual training day. This is a Microsoft 365 fundamentals event, and I'm your presenter, Brian Baldock, a senior program manager within the Microsoft 365 Fast Track organization, as well as a Fast Track architect. So this is what I do all day long, and it's going to be really fun to show you a bit and teach you a bit about what we do within Fast Track, as well as learn about Microsoft 365 fundamentals. So in part one of this event, we'll be covering 3 different sessions, and what we'll be focusing on at the very beginning is setting your baseline, setting your fundamental understanding of cloud concepts. And then session 2 will be focused on Microsoft 365 apps and services, including Microsoft 365 tenants, as well as productivity and collaboration solutions. In session 3, we'll continue learning about M365 apps and services, but really starting with endpoint modernization and management concepts, as well as deployment options in M365. We'll also be touching on analytic capabilities that are available as part of the platform. And then part 2 of the event is where we're going to start looking at Microsoft 365 security and compliance capabilities. And then finally, we're going to wrap everything up in a nice ribbon with M365 licensing, service, and support options. So let's get started with session 1, where we're going to learn about cloud computing. It covers such topics as cloud concepts, deployment models, and understanding shared responsibility in the cloud. So we're going to set our baseline, and then we're going to build on top of that. Let's get started. So let's get started with the session learning about cloud concepts. So in this session, we want to explore cloud computing, cloud benefits, as well as cloud service types. And the learning objectives introduce you to cloud computing, essentially. So we're setting our baseline for our understanding of what the cloud is and how it works. And it covers things such as cloud concepts, deployment models, understanding and shared responsibility in the cloud. And after completing this learning objective, you should be able to define cloud computing, describe the shared responsibility model, define cloud models, including public, private, and hybrid, and identify appropriate use cases for each cloud model. Then we'll take a look at describing the consumption-based model, as well as compare cloud pricing models. So these are all the things that you should learn through the session today. Cloud computing is the delivery of computing services over the internet, essentially. That's what it comes down to. You're borrowing resources from somebody else's computer. And so these computing services include common IT infrastructure. It could be virtual machines, could be storage, could be databases and networking. Cloud services also expand on the traditional IT offerings to include things like Internet of Things or machine learning and artificial intelligence. So because cloud computing uses the internet to deliver these services, it doesn't have to be constrained by physical infrastructure in the same way that a traditional data center is. So that means if you need to increase your IT infrastructure rapidly, you don't have to wait to build a new data center. You can use the cloud to rapidly expand your IT footprint. So some definitions can be found at the following link, but essentially we're covering the main concepts, which are compute, networking, and storage. So let's talk about the different types of clouds, essentially. So let's start with the private cloud. So a private cloud is in some ways the natural evolution from a corporate data center. It's a cloud that is delivering services maybe over the internet for the most part, and is used by a single entity. So it's still the corporate data center, but it's a private cloud, segmented and protected in the same way that a corporate data center might be, but it also provides much greater control for a company and also its IT department. However, it also comes with a greater set of cost, as well as greater responsibilities around how to manage it. So the cost can be greater and fewer of the benefits of the public cloud deployment. So that's where we start getting into seeing how we can weigh the two together, essentially. So it can also be hosted from your on-site data center, and it also might be hosted in an official, or a dedicated data center that's off-site. So even potentially by a third party that has a dedicated data center for your company. So you can rent, a rack space in a protected data center, and that's also an option. Now, if we talk about public cloud, something like Azure, a public cloud is built, controlled, and maintained completely by a third-party cloud provider. So with a public cloud, anyone that wants to purchase cloud services can access and use resources, and the general public availability is a key difference between public and private clouds. So A public cloud is something that's owned by a cloud service provider or a hosting provider, and it provides resources and services to multiple organizations and users, and is primarily accessed over a secure network, which is typically the internet. A hybrid cloud is a computing environment that uses both public and private clouds. And it's in an interconnected way. So it's usually an interconnected environment in some way or shape or form. So a hybrid cloud environment can be used to allow private cloud to surge for increased temporary demand by deploying public cloud resources. So the hybrid cloud advantage is that it's there if you need the public cloud to help take on some demand that your private cloud can't handle. So the hybrid cloud can be used to provide that extra layer of security as well. So users can flexibly choose which services to keep in the public cloud and which to deploy to their private cloud. Keep in mind though that there is this concept of a hybrid server. It doesn't actually exist. There's not a hybrid cloud server that exists. You've got servers that run services that intercommunicate, that have a possibility of talking to each other and are aware of each other in some way, shape, or form. But there's not a server that's actually a hybrid server. You're just deploying and making sure that these services intercommunicate correctly. So an example would be, say, Exchange Online. You have an Exchange server on-premise that is aware and able to communicate directly with your Exchange Online service through other tooling such as Azure AD Connect or something like that. So hybrid cloud models have pretty much the following characteristics. You're looking at resource location. So specific resources run or are used on a public cloud, and others are run in the private cloud. You've also got cost and efficiency, so you can kind of choose the best of both worlds. Hybrid cloud models allow an organization to leverage some of the benefits of cost. So you can take advantage of the lower cost of cloud services in the public cloud, efficiency and scale when they're needed, but you also have your stability and use case of your hybrid local cloud if you need it. You also get that additional control where organizations retain management control of the private cloud, and then the public cloud is, through compliance, handled in a different way. And then technical skills, right? Obviously, technical skills are still required to maintain that private cloud and ensure that both cloud models operate effectively together. There's also this concept of a fourth cloud, and this is increasingly more and more likely, which is called multi-cloud. So a multi-cloud scenario, you use multiple public cloud providers and maybe use different features from different cloud providers, or maybe you just started your cloud journey with one provider and in the process of migrating to a different one. So regardless of the multi-cloud environment that you deal with, which could be two or more public cloud providers, and that's ultimately what a multi-cloud scenario would look like. Just two cloud providers that are working together to provide you with the services, or you might just be in the process of migrating between them. So moving on, essentially when we're looking at public cloud, we're looking at no capital expenditures to set up, or to scale up, because when we're talking about capital expenditures to scale, the public cloud is already ready to assume that scaling. We don't have to buy additional servers to deploy into the public cloud. They're already available. We just have to start taking advantage of them. Applications can be really quickly provisioned and deprovisioned, and you only pay for what you use. When we're talking about a hybrid or a private cloud, hardware must be purchased to start up and maintenance, and then organizations have complete control over the resources and security, which might be advantageous for some organizations, whereas for others that might not be the top concern. And organizations are responsible for maintaining that hardware and ensuring that everything's up to date. And then hybrid clouds provide that better flexibility, right? Where you can have some applications running on premise and some applications running in the cloud, and you control the security and compliance and legal requirements across both. So let's talk about CapEx and OpEx. So when we're comparing IT infrastructure models, there are really two types of expenses to consider. You've got your capital expenditure, which is your CapEx, and your operational expenditure, which is OpEx. CapEx is oftentimes your upfront expense, right, to purchase and secure tangible resources. So you need to buy a rack, you need to buy a data center, you need to buy a building or rent a building. You might have to repave the parking lot, pay for the power, water, facilities that people will use that are taking care of the data center. Those are all examples of CapEx. In contrast, OpEx is spending money on services or products over time. So if we're renting a convention center or leasing a company vehicle or signing up for cloud services, those are all examples of OpEx. And cloud computing falls under OpEx because cloud computing operates on a consumption-based model. So with cloud computing, you don't pay for the physical infrastructure or the electricity. You don't have to pay for the security or anything else associated with maintaining the data center. Instead, you're just paying for the IT resources that you use. And if you don't use any IT resources this month, then you don't pay for any IT resources. So essentially, CapEx is your spend on physical infrastructure upfront. Then you deduct the expense from your tax bill as well as your high upfront cost, but the value of the investment reduces over time. So, the data center that's already paid off, that you don't pay any, the equipment's already purchased, you still have 5 years of runtime left with your servers, then over time that expense will reduce. However, operational expense looks at the spend on services or products that are as required. You get the bill immediately, and then you can deduct those expenses from your tax bill within the same year. So you don't have any upfront cost, you're just paying for what you use essentially. Now let's talk about consumption-based models. So when we're looking at a consumption-based model, there are many benefits, and that brings, benefits like no upfront cost. You don't have to purchase and manage costly infrastructure. Looking back at the CapEx, OpEx slide. The chances are, even if you do end up purchasing those servers, you're likely not using them to their full potential. You're likely not using the infrastructure to its full potential. So ultimately, it's taking advantage of that aspect to, look at this from a consumption-based perspective, and switching to the cloud lets you take advantage of that functionality. So the ability to pay for additional resources essentially when they're needed. So you need to scale this server, you need to add additional bandwidth for it, then you just purchase it as you need it, reduce it afterwards. And then you can just stop paying for resources that are no longer needed. So as long as you're not using it, you're not paying for it. So let's start digging into describing the benefits of using cloud services. So this learning objective introduces you to the benefits of cloud computing, and it can offer you and your organization, a good view over how we can take advantage of the cloud to its fullest. So what we're going to look at here is what you should learn after this objective essentially is being able to describe the benefits of high availability and scalability in the cloud. You'll be able to describe the benefits of reliability and predictability, as well as security governance in the cloud, and talk about some of the advantages of manageability for the cloud. So when we're building or deploying a cloud application, two of the biggest considerations are uptime or availability, and the ability to handle demand or scale as necessary, right? Uptime and scale are two really important factors that affect the performance and reliability of cloud applications. So uptime, also known as availability, is the percentage of time that a cloud service is operational and accessible to its users. Scale, also known as scalability, is the ability of a cloud service to handle increasing or decreasing demand for resources without compromising the quality or functionality of the service. Uptime is measured in nines. So I'm sure everybody's heard the term 5 nines. Well, that's pretty much that determines how much downtime is allowed over a specific period of time for a cloud service. So for example, 5 nines or 99.999% uptime means that the cloud service can only have about 5.26 minutes of downtime per year. So uptime is affected by various factors. Things such as network failures, power outages, hardware malfunctions, software bugs. You could have a cyber attack or a natural disaster, and even sometimes human errors, because that never happens, right? So to ensure that high uptime, cloud providers use various techniques. So really to make sure that this high uptime remains something that's possible. But these cloud providers, what we'll use is things such as redundancy, backup and failover. We'll do load balancing, definitely keep monitoring all the services, and then disaster recovery in the worst case scenario. So scaling, on the other hand, is the ability of a cloud service to adapt to changing demand for resources. things such as cloud computing, so computing power, storage space, memory, bandwidth, users. Scale can be achieved in two different ways. We've got a thing called vertical scaling and horizontal scaling. So vertical scaling, which is also known as scaling up or down, involves adding or removing power to an existing cloud server by upgrading or downgrading its memory, which would be its RAM, storage, or processing power. Horizontal scaling, also known as scaling in and out, involves adding or removing servers or machines to a cloud system by linking them together. So scale can also be elastic or static. An elastic scale means that the cloud service can automatically and seamlessly add or remove resources on demand. A static scale means that the cloud service requires manual intervention to add or remove resources. So uptime and scale are interrelated and necessary and essential for cloud applications, because a high uptime ensures that the cloud service is always available and also responsive to users, and then a high scale ensures that the cloud service can handle varying levels of demand as well as traffic without losing any quality or functionality. So together they really enable cloud applications to provide reliable, high performance and cost-effective solutions for businesses. So let's explore what that really means. So vertical scaling is also known as scaling up or down, right? And that involves adding or removing power to an existing cloud server by either upgrading or downgrading its memory, RAM, storage, or processing power. Then we're talking about horizontal scaling, which is also known as scaling in or out, and that's adding or removing machines to a cloud system by linking them together. So when we're talking about, again, vertical scaling, we've got a server. We want to add or remove some RAM. So we want to upgrade it to 12 gigs of RAM, and then we want to downgrade it to 8 gigs of RAM. Next up, if we're trying to talk about horizontal scaling, which is scaling in and out, we want to add additional servers that have 8 gigs of RAM until we've got the right amount of servers that help us run our service correctly. So both vertical and horizontal scaling can help improve the performance and reliability of a cloud service, and this is by adjusting its resources according to the demand and workload. There are some advantages and some differences, really. So there are trade-offs between the two scaling methods. Vertical scaling is a lot easier and faster to implement, but it does have a bit of a limit on how much power can be added to a single server. So that depends on the cloud service that you're using. Vertical scaling also can require downtime. It can also be more expensive and less efficient because it does require buying and renting more powerful servers that might not fully be utilized. And horizontal scaling in that sense is a lot more cost effective because it allows paying for only the resources that are needed and used. So vertical scaling is more suitable for applications that have a high CPU or memory requirement, such as databases or analytics. And then horizontal scaling is more suitable for applications that have a really high demand on user or traffic requirements, such as web servers or streaming services. Now let's talk about automated scaling, or this type of scalability or elasticity that can be automated. So it's really just a term that refers to a process of adjusting the resources of a cloud service automatically based on predefined rules and policies. So this type of scaling can improve the performance, reliability, and cost efficiency of cloud applications by dynamically allocating and releasing resources. So we're just looking at the demand, looking at the workload, and scaling as needed. Right. So automated scaling is also known as auto-scaling. It could, a bunch of different terminologies can be used across different cloud providers. There's also concepts such as reactive or proactive scaling. So reactive being that if something changes in the current load or utilization of the cloud service, then we're going to add additional CPU or whatever is required to balance that load. And then proactive scaling is something that anticipates the changes in potential future load by just looking at tendencies and looking at those metrics in order to make a decision based on that. Then there's also the concept of scheduled scaling. Like if we know that this server is going to get a ton of traffic because we're adding something new, a new video game's coming out or something like that, let's make sure that we already have the servers in place and scaled properly to ensure that the functionality works. So what that looks like, again, is we've got a server. It hits 80%, and we automatically deploy a second server. When that hits 80%, we're going to automatically deploy a third server. And then when that hits 80%, let's deploy a fourth, onwards, and that just scales out until we no longer need it, until the service hits its maximum limit. So when we're talking about monitoring for that kind of auto scale functionality, Azure has that functionality and is part of the app service or virtual machine scale sets, and that's something you can definitely check out. But it's really ultimately just an important feature of cloud computing that enables cloud services to adapt to changing demand in rapid and automated ways without requiring human intervention. So by using this type of scaling, you can optimize your resource utilization and cost efficiency because you can downgrade as needed as well, and improve your availability and reliability in the long run. So let's kind of discuss some other concepts here. So if we walk through each of these individually, and I'll be clicking through a little bit too, let's talk about high availability. So the concept is that a cloud service is designed to always be accessible and operational. And that's regardless of any failures, outages, disasters that might occur. Cloud providers use a ton of different techniques, which we already touched on, talking about redundancy, backup, failover, load balancing, monitoring. So essentially high availability just really means that users can access their data and applications anytime, anywhere without interruption or downtime. Now, if we're talking about elasticity, cloud service can automatically and seamlessly adjust their resources according to current demand and workload. So that's where we were talking about the auto scaling sort of approach, right? If we're looking at elasticity, cloud providers use techniques such as auto scaling, provisioning, and deprovisioning, and that enables elasticity of their services. So elasticity really just means that users can optimize their resource utilization and the cost efficiency that's related to that dynamically, and that allows us to allocate and release resources as needed. Oops, I went too fast there. Scalability. So if we're talking about scalability, cloud services can handle increasing or decreasing demand for resources without compromising quality or functionality. Cloud providers use a lot of techniques, such as virtual scaling and horizontal scaling. So we already touched on those and described how they work in the way that they are meant to function properly. So vertical scaling involves adding or removing power. Horizontal scaling involves adding or removing machines. So scalability ultimately just means that users can meet their performance and reliability requirements by scaling the resources up and down or in and out as needed. And then reliability, well, we touched on that a little bit talking about the 5 nines, right? So cloud services are designed to be consistent and dependable. So regardless of any errors, faults, or disruptions that can occur, and that ties to high availability, right? So availability, reliability, scalability, all that ties in together. Now, if we're talking about predictability, cloud services are designed to be transparent and controllable. So regardless of any changes or variations that may occur, cloud providers use techniques such as metering or billing reporting and auditing to ensure that predictability of their services. So, you're not going to get a surprise bill for something that you weren't aware of being used. The reporting's there, it's transparent. It's just ensuring that you're actually consuming what you're paying for. And so that helps us comply with various regulations and standards. And now when we're talking about security, well, security is necessary for cloud providers because cloud services are designed to be secure and protected. And that really is regardless of any threats or attacks that could occur. So cloud providers use techniques, like encryption, authentication, authorization. We have firewalls, antivirus, intrusion detection, physical securities as well. So we can ensure that users have safeguarded their data correctly and applications from unauthorized access or damage. So that's really a crucial aspect around cloud providers. And then we've got this concept of governance. So cloud services are designed to be governed and regulated regardless of any policies or rules that may apply. So cloud providers use techniques such as identity management, role-based access control, policy enforcement, compliance management. And we've also got concept of data sovereignty. And that's just to make sure that the governance of the services are effective and legal, right? So governance means that users can define and implement their organizational objectives and standards across the cloud environment. And then finally, we've got manageability. And so manageability is the concept of making a cloud service manageable. And they're all designed to be manageable and operable. But it's just like learning a programming language. Oftentimes the concepts are the same, it's the syntax that's different. So cloud providers do have their own methodologies of managing. Azure, for instance, you've got a bunch of different ways that you can manage Azure. So if we're talking about the different tasks and operations that might be required, cloud providers use techniques such as automation, orchestration, configuration management, service management. You can talk about support management to ensure manageability of their services, but ultimately it just means that users can simplify and streamline their cloud administration and maintenance activities. All right, so now let's talk about the different cloud service types and share some of the use cases and benefits that align to each of the service types. So after completing this learning objective, you should be able to describe infrastructure as a service, or IaaS, platform as a service, or PaaS, and software as a service, which is SaaS. And you should be able to identify appropriate use cases for each of these cloud services. So IaaS is essentially the most basic cloud computing service category. So you build that on a pay-as-you-go kind of infrastructure model by renting servers, virtual machines, storage, networks, and operating systems from a cloud provider. It also provides instant computing infrastructure and provision. So essentially it stands for what it says here on the screen, which is infrastructure as a service, which is a type of cloud computing service that offers essential compute, storage, and networking resources on demand and on a pay-as-you-go basis. So it's one of the three different types that we're calling out here. We've got the SaaS and PaaS and IaaS. IaaS has many benefits for businesses, such as reducing CapEx and optimizing costs by eliminating the need for configuring and managing that physical data center. It also increases scalability and flexibility by allowing businesses to easily scale their resources up and down, and that's on demand essentially. Improving reliability and availability by ensuring that the infrastructure is always operational and accessible to users, and enhancing security and protection by safeguarding the data and those applications from unauthorized access or damage. So this helps enable innovation and agility by allowing businesses to quickly deploy new applications and services. Now let's talk about platform as a service. So this essentially provides us an environment for building and testing and deploying software applications. It helps create applications quickly without focusing on the management of those underlying infrastructures. So PaaS, or platform as a service, is a type of cloud computing service that provides this complete, flexible, and cost-effective cloud platform, which helps us develop and run and manage these applications as we need them. So PaaS allows us to avoid the expense and complexity of buying and managing software licenses and the underlying application infrastructure and the middleware, or the development tools and other resources. So you manage the applications and the services that you develop, and the cloud service takes care of everything else. So some of the benefits of PaaS are that it can reduce the time and cost of developing and deploying applications by providing pre-built software components and the tools that you need without having to code them yourself. It can also increase the scalability and flexibility of your applications by allowing you to easily scale up and down your resources according to demand. And it can improve the reliability and availability of your applications by ensuring that the platform is always operational and accessible to users. It can enhance the security and protection of your applications by safeguarding them from unauthorized access or damage. And it can enable innovation, obviously, by providing that agility that lets you quickly deploy those applications and services. Some examples of PaaS, is Microsoft Azure, for instance. It offers a bunch of different features and services that support full web application lifecycle, such as operating systems, middleware, databases, development tools, business intelligence. I could go on and name a ton, but PaaS is a great platform for building and developing your applications. Now let's move on and talk about software as a service. So a common usage usage scenario for a software as a service or a SaaS is Microsoft Office 365 or Teams or Dynamics CRM Online, things like that. SaaS, or software as a service, is a type of cloud computing service that provides users with access to software applications over the internet. So users don't need to install, update, or maintain the software on their own devices. The cloud provider takes care of that. So you only pay for the software that you're actually using as well. So usually on a subscription or a pay-per-use basis. SaaS is one of the three types of cloud services, right? So it fits alongside infrastructure as a service or platform as a service. Some of the benefits of SaaS are that it can reduce time and cost of developing and deploying software applications because it provides you with that ready-made software component and tools that you can use without any coding. It can also increase the scalability and the flexibility of those software applications by allowing users to easily scale up or down the resources according to demand. It can provide reliability and availability of the application just by essentially ensuring that the software is operational and accessible to everyone, everywhere, all the time. And it can enhance the security and protection of the software applications by safeguarding them from unauthorized access or damage. It can also enable and innovate, and provide agility by allowing users to quickly deploy new software applications and services. So, Microsoft Office 365, Microsoft 365 is a SaaS solution. And so they offer, it offers various features and services that support different business functions, but essentially, office productivity, collaboration, customer service management, e-commerce, those are common scenarios where we'll see a SaaS application come into play. So let's just review what they look like side by side. Essentially, this slide just gives you a side-by-side comparison of IaaS, PaaS, and SaaS. So a really bullet point view of what the three different solutions look like. So let's talk about the shared responsibility model. The shared responsibility model is a framework that defines the roles and responsibilities of both Microsoft and the customer in securing and managing the cloud environment. Microsoft is responsible for the security of the cloud, which includes the physical infrastructure, hardware, software, and network components that power the cloud services. And Microsoft also provides various tools and features to help customers secure their data and applications in the cloud as well. So things like encryption, identity management, compliance management, threat protection. But ultimately, the customer is responsible for security in the cloud, which includes the data and the applications that they store and run in the cloud. So that also includes the configuration and management of their cloud resources. So the customer also needs to follow the best practices and policies that are used to protect the cloud environment from unauthorized access and damage. So the level of responsibility varies depending on the type of cloud service that the customer uses. Things such as a software as a service or a platform as a service or even an infrastructure as a service might have different responsibility guidelines, and you can kind of see that here on the diagram that's on the screen. So for SaaS, such as Microsoft 365, Microsoft is responsible for most of the security aspects, such as the application, the network, the operating system, and the physical infrastructure. The customer is only responsible for their data and the identities, as well as controlling access to the cloud service. For platform as a service, something such as an Azure App Service, Microsoft is responsible for the security of the network, the operating system, and the physical infrastructure, whereas the customer would be responsible for their data applications, as well as controlling access to the cloud service and configuring their platform settings. And when we're talking about IaaS, something such as an Azure Virtual Machine, Microsoft is responsible for the security of the physical infrastructure, and that's pretty much it. The customer is responsible for their data, the applications, controlling access to the cloud service, configuring their network, the operating system, as well as the virtual machine. So you can see how the different segmentation across the different areas can lead to different responsibility models. So just by reducing complexity and moving towards a SaaS model, we're already reducing where we as a customer would be responsible for particular parts of the service. So you can see how it can optimize and improve performance. So remember, you'll always be responsible for the information and data stored in the cloud, devices that are allowed to connect to your cloud, so cell phones, computers, so on. the accounts and identities of the people and services, and also those devices in your organization. So the cloud provider is always pretty much just responsible for the physical data center, the physical network, the physical hosts, and your service model is ultimately going to determine responsibility for things like operating systems, network controls, applications, and infrastructure. So this concludes session 1. So let's take a quick recap on what you've seen so far. So we defined cloud computing. We also described the shared responsibility model. We looked at different cloud models, including the concept of public, private, and hybrid clouds. And we also identified appropriate use cases for each of these cloud models. We took some time to describe the consumption-based model, and we compared cloud pricing models. So now we're going to take a quick 10-minute break before moving on to session 2, and so I'll see you shortly.